made a difference. We made it together. We made it. Dams are one of the coolest marvels produced by engineering. They vary in size. They have tons of uses, such as generating power, helping farmers, and saving wildlife. Structural engineers who design dams work closely with environmental engineers and ecologists to ensure they cause minimal environmental, ecological, and social disruption. Dams are built for a variety of purposes, including recreation. The reservoir may form a lake large enough for recreation, such as boating, fishing, and swimming. Water source. Some reservoirs act as a consistent water source for fighting fires, farm irrigation, and domestic use, such as drinking, cooking, washing, and lawn watering. Flood and drought control. Dams are important for controlling flooding and drought. During times of excess water flow, the reservoir acts to contain water, which can then be released during times of low flow. Retention of contaminants. Contaminated wastewater from mining and other industries can be retained in reservoirs to prevent its release into surrounding waterways. Navigation. Dams are also used in lock and dam systems, which allow boats to navigate waterways, which have drastic changes in elevation. Hydroelectricity generation. Some dams are massive engineering marvels which control the release of water to create hydroelectricity, a clean energy alternative which can provide power to thousands of homes and businesses. Forces acting on a dam. When engineers design a dam, they must consider the maximum forces which could act upon that structure. The main force acting on a dam is the weight of the water pushing against the wall. The force of the water causes a compressive force against the dam. In order to prevent failure, the dam must be built strong enough to push back against this compressive force. Other forces include the weight of the dam pushing downward, wave pressure, and earthquakes. The challenge. You and your team of engineers has been given a job of designing a dam that must stop the flow of water in a river. You will be designing and building a model of your dam to test in a simulated river. In addition to stopping the flow of water, your dam must be able to control the release of some water and then stop it again. First, your team will choose one of 3 scenarios. Then you will design and build your model to meet the needs of your client. Scenario 1, flood control. Your community relies on the food produced by a local farmer. Due to climate change, the volume of water in the river during the spring has become too big and has started to cause floods, which have been decreasing crop yield. Build a dam to control the spring flooding. It will prevent crop loss and allow for irrigation during times of drought. Scenario 2, hydroelectric dam. Recently, your city hall decided to become a more sustainable community, but it does not have a sustainable source of electricity. Become the first sustainable community in the area by building a hydroelectric dam. Scenario 3, wildlife habitat. Due to climate change, wet springs and periods of drought have changed the habitat of an endangered species of turtle which lives in the river. Build a dam which helps maintain and restore the turtle's habitat. This will help the species to breed and will save it from extinction. The materials. You may use any of the following materials: cardboard, foil, plastic wrap, popsicle sticks, PVC pipe, string, wire, skewers, straws, springs, tape, glue, clothespins, plasticine to secure the dam to the sides of the simulated river, and recycled materials like yogurt cups, water bottles, juice boxes. As you work, remember the engineering design process. First, we must research and understand the problem, design a solution, build a model, test and redesign. Consider the different forces that may be at play when you build and test your design. Good luck!